So we've sort of finished up the section on linear equations in one variable. So we started with solving linear equations in one variable, we moved on to solving the literal formulas, and then we went to the creating the linear equations through word problems that we could then solve. The next part of this chapter is related to linear inequalities, still in one variable. So an inequality relates algebraic expressions using symbols less than, greater than, less than or equal to, greater than or equal to. We solve an inequality by figuring out what numbers will make the inequality true. And the biggest difference between an equality and an inequality is there's not just one number. So when you're solving a linear equation in one variable, the answer is like 3 or 5 or 6. But when you're solving an inequality, there's a ton of solutions. So for example, if I wanted to find the values of x that are less than or equal to 2, well, 2 would be a solution, right? 1 would be a solution, 0 would be a solution, negative 1 would be a solution, negative 0.626 would be a solution, right? All the values of x that are less than or equal to 2 are solutions to this inequality. And to me, that's the biggest difference, right? Not just one solution, but a whole range of solutions. So because of that, we need to learn how to write all of our solutions, because I don't want to go through and be like 1, 1.1, 1.01, 1 point, right? You don't want to do that. And so one way of doing it is how I've written it here. X is less than or equal to 2. This is called set notation. So set notation is when you solve a linear inequality, you end up with this inequality like x is less than or equal to 2. And the reason it's called set notation is because even though we write it like this, we could write it like this, right? We could use our set brackets. It's the set of x such that x is less than or equal to 2, or simply just x is less than or equal to 2, or you could put the set brackets just around that part, right? There's lots of variations of that, but that's set notation, pretty simple. The second way of showing our solution is by graphing it. So if I wanted to show all the values of x that are less than or equal to 2, I would draw a number line, and I would show with an arrow all the values that are less than or equal to 2. Now the next question is, how do I show that it's less than or equal to 2 versus just less than 2, right? Because all these numbers to the left are less than 2. But if I want to show it's less than or equal to, I use a different bracket than if it's just less than. So a round bracket indicates that the endpoint is not in a solution set, whereas a square bracket indicates that an endpoint is in a solution set. I can't remember what I wanted in that fill in the blank there, but this will work. Maybe I had not included, right? And then here I had is included. It doesn't really matter. Okay, so the biggest difference is that if it was x is less than 2, you would do a round bracket to the left. And if it's x is less than or equal to 2, we do a square bracket to the left. My reasoning behind this is if you look at the if you look at the square bracket, if you look at the top bits of it, if I go like this, there's your equal sign, right? So I remember square is equal because it makes the equal sign, whereas the round bracket doesn't make an equal sign. That's just kind of an easy way to remember it. And then the third way of displaying an answer is that we all love graphs. Graphs are awesome, but they take a lot of work, right? You got to like draw the number line, and then you got to put on the square, and then you got to put some numbers there. So interval notation is a shortcut to your graph. So what it is we take the important information off of the graph. So we care that it's starting at -2 with a square bracket. And then where's this arrow going to? Well, it's keeping on going to the left down to -infinity. So the interval notation of x is less than or equal to 2 would be this. Square bracket 2, and then we show that it goes to the left forever. So we're going to, on the next page, kind of look at all the different sets that we can come up with. But the one thing I really want to point out too is that if a graph does go all the way to the left, it goes down to -infinity. If it was to go all the way to the right, it would go to +infinity. But you're always, always, always going to use a round bracket on your infinities. So if you look here, and the reason is because infinity isn't like a concrete number. We don't actually know where it's going to end. And so we use round brackets instead of square brackets to show that it's up to infinity, but we don't exactly know where infinity is, right? It keeps going on forever. So how do you be equal to it? All right. So instead of reading all this stuff, what I now want to do is look at these 3 types of ways of displaying solutions and kind of go over what the different ways they can look like. So the first one we can start with is x is all real numbers greater than 2. So same number, but different inequality sign. So if I wanted to show that x is all real numbers greater than 2, I could show that in set notation, right? X is greater than 2. I could put that on a graph, round bracket it on 2 and going with an arrow to the right, going up to infinity. To take that interval notation, or sorry, graph into interval notation, I take the round bracket on the 2 and then I show that it goes up to positive infinity. So now let's look at another example. What if I gave you the solution in interval notation? Could you graph it? Could you write it as set builder notation? Could you then write it in words? So this one, what is it? Well, it's starting at 5. It looks like it's including 5 because it's a square bracket. So I'm going to put a 5 on my number line. I don't really care where you put it. Now the square bracket's to the left, so I can already put my square bracket to the left. So it's going from 5 down to negative infinity. So I'm just going to put an arrow going to the left. How would I describe that in set notation? Well, I'd say x is any value less than 5. And because it's a square bracket, I would say less than or equal to 5. Now again, you can leave it like that. If you want to be special, you can put your set brackets around it. If you want to be really special, you do the set of x such that x is any value less than or equal to 5. And then again, in words, that would be x is, now technically we should write this, right? All real numbers. We wouldn't want those fake numbers in there. Less than or equal to 5. All right. The next one is what I like to call an x sandwich. So you'll notice that this is x in the middle. So if I was to read this, it would be x is greater than negative 5, but also less than 2. So x is greater than 5 and less than 2. Okay, that's what these symbols mean. So I know I always said, like in the review chapter, I said read your inequalities from left to right. That changes when you have an x in the middle. So always read it in terms of x. So how do I graph that? Well, I'm going to put a negative 5 because it's the smaller number on the left. I'm going to put the 2 on the right. To show that x can be greater than 5, I'm going to do a round bracket on 5 with an arrow going to the right, but it has to stop at 2. And there we go. And so then if I was going to take that and put it into interval notation, I literally just take the numbers and put the brackets on them. And I just take out the number line. All right, there's 2 more here. Feel free to pause or just keep listening if you need some help. So the next one is x is all real numbers greater than or equal to 1 and less than 7. So maybe you would find it easier to start with a number line. So my numbers are 1 and 7. So I'm going to put a 1 because it's smaller on the left and a 7 on the right. Okay, I have to be greater than or equal to 1. So I'm going to put a square bracket pointing to the right on 1 and less than 7. So that's a round bracket pointing to the left on 7. Interval notation, just take out the number line. And then in set notation, this is a sandwich. X is sandwiched between 7, so it's less than 7, and greater than or equal to 1. Last one is, how do I show that x is all real numbers? Well, in set notation, I just go x is an element of the real number system and call it good. Okay. On a number line, you would just draw a solid line with arrows to the left or right. There's no starting, there's no stopping. So where is it going down to? Well, it's going down to negative infinity. It's going up to positive infinity. So interval notation would be negative infinity to infinity. So that is how to use, or an introduction to, interval notation.